and welcome everyone to our presentation today. Just as a forewarning, I might go slow here just because we were kind of going in a dry run and I was having some technical difficulties. So I've got my programs closed down in the background, and when I do my demo, I'm going to open them up one at a time. Hopefully that will alleviate some of the issues. So just a quick slide here for those of you who aren't familiar with us at IMAGINiT. We are a partner with Autodesk, meaning we supply licensing and training to all things Autodesk related. For this presentation, I'll be showing some Twinmotion. We have a partnership with Epic Games as well. So Epic Games is the owner or the developer of Twinmotion. So kind of crossing platforms, and actually Jay's going to be talking about some different Leica workflows. So really kind of touching base on a few of our different specialized software areas, but Autodesk being the primary one, as probably most of you are aware. So Jay, you want to do your quick intro here?
Sure will, Vince. And Vince, if we could, I don't know about everybody else on my end, everything's getting cut off a little bit. So on the right-hand side, all the wording seems to be getting cut off. But while you look into that, I will go ahead and talk a little bit about kind of where I've been and what I've done here at IMAGINiT. That's much better, Vince. Thank you. I've got 25 years of experience in the field and kind of cut my teeth with the Civil 3D and civil applications for Autodesk. I'm a certified instructor, and you know, for the past several years anyway, I've been on the reality capture side of our business, of course with Autodesk's Recap family, Leica Geosystems high definition scanning software, and again AutoCAD Civil 3D and all the AutoCAD products.
Cool, thanks Jay. Did it cut off here because I collapsed this panel down?
You're good now.
Good? Okay. Some weird go-to-meeting glitch.
You're perfectly fine, Vince.
We're good? All right. So for myself, I'm Vince Danielli, Building Solutions Division Team Manager here at IMAGINiT. Got over 15 years experience in the industry. I am a certified instructor, ACI, professionally with Revit, AutoCAD, 3ds Max, and my areas of specialty are really anything related to BIM, architectural visualization, Revit, 3ds, Twinmotion, some Unreal Engine, but many other programs that go along with that. So, yeah. So I will flip that back to Jay here, and I'll try to run the slideshow as best as possible.
Appreciate it. All right. So one of the first questions we have to ask ourselves is what is reality capture? And I know that seems like a very simple question, but there are some really broad strokes when it comes to reality capture and many different areas we can kind of dive into. So reality capture allows us to allows the design process to happen in context with our existing surroundings. So we know kind of where we are and where things are in the field with some of the reality capture solutions. The first one that we have here is 3D laser scanning, and it's becoming more widely adopted throughout all industries, where we take a terrestrial scanner out, create several scans, and then piece all of those scans together to create one big point cloud. We have aerial LiDAR, which, you know, can be many different things, where it can come from a plane, it can come from a drone, things like that, essentially still using a laser to capture our data. Photogrammetry is, again, another one that's becoming more and more popular, where we're taking a bunch of photographs and, again, being able to piece those together to come up with ortho imagery or 3D point clouds. Where mobile LiDAR we can attach to a vehicle and drive down the road, and at about 20 to 45 miles an hour, capture a point cloud simply by driving the road with a scanner on top.
And Jay, is that something like Google Maps or Street View? They're using mobile LiDAR, right?
It's very similar, but what they're doing is more of a 3D picture, whereas the mobile LiDAR actually has a scanner on the roof of a vehicle, and it's sending out lasers in 2 different directions to capture the point cloud that way.
Awesome.
We have ground penetrating radar, where we can walk along with a cart and be able to get data beneath the ground without having to do a lot of digging. Sonar mapping, where we can go across the ocean floor, be able to pick up things that have been placed under the ocean, and essentially map the ocean floor, not only with its topography, but with its with all the wires and cables and things like that have been placed. And then our last is even a tape measure, paper and pencil. So even though, you know, we're not buying expensive equipment, going out with a tape measure to capture the dimensions of a room or find out where a door is or a window is, that's still capturing reality. All right, so we have to ask ourselves, what is a point cloud? And essentially a point cloud is just a series of points that end up representing an object that is in a real space. Each point has its own set of X, Y, and Z coordinates, and the clouds are generally produced, as we just spoke about, laser scanners, photogrammetry software, and the points are on the external surfaces of the objects around them. So one of the common misconceptions, with the exception of radar, is that these things can see through walls. They can't. They see up to where the object is, and then they stop. All right, creating meaningful data. One of the questions we often get asked is, great, I've got a point cloud. A point cloud was supplied to me. What do I do with it? Well, a point cloud can be used just simply as a point cloud. It can be used to capture dimension. It can be used simply to place somebody in the space and give them an idea of what the surroundings are without actually having to send them to the field. Right? We can also use that, let me back up here a sec. We can also use that point cloud to create 3D objects and model those objects from the point cloud data. And then, of course, that point cloud data can be modeled into a BIM deliverable, providing us our walls, our doors, our windows, all from point cloud data. Go ahead.
Cool, thanks, Jay. Yeah, so outside of the reality capture and laser scanning, as Jay mentioned, we also have this area that is being more widely used, I think, at really a consumer level, but we're also seeing a lot of professional applications with photogrammetry. And really, essentially what photogrammetry is capturing, instead of bouncing a laser off of a surface, you're just capturing the imagery from all different types of angles around an object. And then using software, I'm sure some of you have done this maybe in like Photoshop before, stitching large panorama images together. Well, taking that application, but actually putting it into a 3D environment, we can stitch all of those images together to create a 3D mesh. And what's great about photogrammetry is not only are we getting the 3D mesh in the surface that we can use in programs like 3ds Max or Twinmotion, but you're also getting that texture and the material that's tied to the image as well. So yes, there is a number of different ways we can clean up the scans, and lighting conditions are very important for capturing really nice, crisp 3D meshes. But it's a great way and a cheap way of just using something that you already have access to in your phone or a camera and creating 3D objects from it. So we don't have to spend $100,000 on a professional grade scanner in order to get simple surfaces in 3D for use, mostly in visualization, but we've seen applications where scanning sites and things, using a GoPro to scan building plots is something that's pretty applicable professionally. Now, this is just something I like to talk about. In my demonstration, I'll show examples of this. But just with scanning with a laser scanner, we do have different levels of photogrammetry. And the mesh density that we create is pretty critical to not only seeing the surfaces as we want to see them, but also in how we process them in the performance of using these very detailed surfaces. So one thing to keep in the back of your mind as we go through this presentation is try to think about how this is going to affect the performance of your models, of the different software that you're using. And one of the things I'll mention is frames per second. So something that maybe if you're into gaming, you understand, but we have to kind of shift that focus now into these different environments and real-time rendering, which Twinmotion produces. So yeah, basically the higher density, the more accurate the surface, but the more it's going to impact the performance of your hardware. And just some solutions here. So Jay and I kind of did a really high-level explanation of reality capture and focus on laser scanning and photogrammetry. There are different solutions that allow us to actually do stuff with that output, or do stuff when we gather these point clouds and these mesh surfaces. And some of the programs here for reality capture, for example, and Jay's going to show a little bit of the Leica suite and Jetstream viewer. But Leica 3DR is used for creating surfaces from either scan data, point clouds, or photogrammetry, I believe. The CloudWorks program is what you're going to actually use to take that point cloud into programs like AutoCAD, like Revit, and use that point cloud data to create your model elements, so something that's actually useful to us in BIM. Recap is just Autodesk's version of that same sort of program to register and to process the point clouds. Pix4D is something that can be used for creating the mesh surfaces for photogrammetry. Same with 3ds Zephyr, which I believe is a freeware. We don't do training in it, but it is a good program out there if you want to kind of tinker around with photogrammetry and test some things out. From a visualization workflow, I'll be showing 3ds Max and Twinmotion and Quixel Megascans, but also this kind of ties into the backbone really of Twinmotion is the Unreal Engine. So our focus here for this presentation is, at least for the visualization side, is on those 4 different programs. So without further ado, Jay, I will turn presentation mode over to you, and you can show everyone some nice point clouds. Let's
see here. Hopefully you guys are seeing Revit there.
Yep, you're good.
Perfect, great. So, like I said earlier, one of the things that we often get questioned about is I have this point cloud, and what do I do with this thing? It seems really cool, but I don't really have a use for it. And we can really solve a lot of problems with point clouds. And in this case, we might take it into something like Revit, where I've loaded the point cloud. And, of course, I can analyze that point cloud by looking at it through different angles. I can even come through here, and if I like, I might just say, well, all I want to see is the floor plan, but guess what? It's a 3D point cloud. I've got the ceiling in the way. We even scanned above the ceiling here. So the CloudWorks application allows us to go ahead and do things like cut through the point cloud along different axes. So I can simply double click, and now I can see the overall floor plan. I can see where the rooms start and stop. I can see which side of the frame the door is on, and maybe even see what's behind the door. A lot of this goes back to, if we went with the tape measure, how often would we have to go back, right? Because we forgot that measurement over here behind a desk or something like that. And then, of course, we can take what's in Revit here and we can turn those slices back off and use them a little bit differently. Maybe make a thinner slice, and that thinner slice can then be used to actually create Revit objects. Now, of course, I could very easily come in here and I could just use the wall command and trace, but the CloudWorks application for Revit has different tools that will allow me to go ahead and use the point cloud to create those walls. So I can create what's called a 2D poly, or a 2-point polyline, and you can see it creates a quick green line there. And I'm just simply tapping on the point cloud data along the wall, and when I do, I can then hit the escape key and I can end my object, choose the type of wall that I want to create, tell it that I want it to appear on the left side of that green line, and set the wall height. I can then say OK, and I've now created a 3D Revit object from the point cloud data. So of course, you could go on and model the rest of this space simply by going ahead and using the point cloud to create walls. There are door commands here. There are window commands here, which will allow you to fully model the over the entire point cloud. Or we could simply take this and forget about all of those options, and we could do something like create a true space. And this true space allows me to, again, kind of take my point cloud and my model and put my model in context with where things are in the point cloud. You can see on the right is the point cloud in Revit, and on the left is the point cloud data from that I scanned. And as I rotate here with the true space, it rotates around in my model. And if we look back here a little bit, we'll be able to see some of the walls that I created kind of through here, and maybe you can't see them there, but they're there. Okay. So what if you don't have a need to use this in Revit? What if you have a need to do something else, right? You want to provide your data to somebody. Well, we can go ahead and use something that Leica creates called Jetstream Viewer. And this is nothing more than a free viewer, right? So when I say free viewer, a lot of people kind of go, geez, it's not going to be that great. Right? Watch this. I can come in here and I can click to look at a 3D point cloud. Now I'm seeing the scan locations that were taken here, where I can double click and I'm able to see the imagery. So once again, putting my data in context so I know what's around. Okay, I can even then kind of come away from that and say, well, I want to create a dimension. So across the top here, I might decide, hey, I'm going to click a point, and then I'm going to click a point over here, and I get a dimension. Or one of the things that we often hear is, well, geez, having to go back and forth between the point cloud and a Revit model. Well, I showed you one solution for that, but what if you wanted somebody else who doesn't have Leica products to be able to see stuff like that? One of the things that we can do is we can incorporate a model. Now, this is a model that was exported from Revit, and I can drag and drop it right here into the Jetstream Viewer software. Okay, I'm going to use the model coordinates, and you can see, oh, geez, what happened? My model doesn't line up perfectly. Well, what do? there are tools in here that will allow me to go ahead and move this. And of course, it's going to not work when I'm ready to demo it. So bear with me 1 second. It often happens when it just needs a good restart. There we go. So the model can be moved around in the point cloud to line up with the point cloud. Okay? And then, of course, we can do things like take somebody for a tour of our building. And you can see I'm creating a quick fly through here where I can speed up or slow down, giving a realistic tour of what this place is going to look like when it's finished. And of course, this tour can be recorded using the video camera and create even an MP4. So if somebody doesn't want to download software, they don't necessarily have to. You can provide them with the video clip and send that through Dropbox or sometimes even email. Okay. All right, Vince, I'm going to pass that back over to you.
All right. Great. All right, so I think I'm sharing now. Can you see it, Jay?
Yes, I can.
Okay, great.
3ds Max is coming up.
Yeah, I did not want to launch this up when we were doing our dry run. I had Revit, 3ds Max, and Twinmotion open at the same time, and it didn't go over so well over the go-to. So hopefully my files are still here. Let me move that out of the way. So yeah, kind of taking a step back, and I guess actually, so what Jay was talking about with that CloudWorks for Revit, the plugin that allows us to actually model off of the scan. We've got this example. This is our Richmond office, Richmond, Virginia, that Jay and one of our other guys, Jeff, scanned using a Leica scanner, processed the point cloud, and then using that workflow that Jay was talking about, we were able to produce, the 3D model, extremely accurate based off of the points with windows and everything. So, complete model. I don't have the point cloud loaded in, but that's fine. I just wanted to show that, yes, this was built off of the scan, so we can absolutely go from scan data to BIM data or BIM model using those techniques. I'll get back to this once we get to Twinmotion. That's kind of the whole point here, but just to show you the end result. So I'm going to go kind of quickly through this stuff because I want to leave enough time for a good Q&A panel, Q&A session at the end. But let me see. Hopefully, when I crashed, I did save this. So let me check. Where was my recent? Yeah, open recent. Please be in here. Okay, it's not in. So I'll build this from scratch. That's fine. I think I know this well enough where I can do it pretty quickly. But what I wanted to show here, I mentioned earlier in the PowerPoint about how when we use photogrammetry, we can have different levels of detail in mesh density when we process a mesh using photogrammetry. So one thing that is pretty cool is this up, and I'll get to this Quixel Megascans, which also crashed because it happened 2 minutes before presentation. Always plan on the worst, right? But anyway, let's see. Back up where am I? Asset library. Okay. All right, so I think this is where, let's see, downloaded. This is it. All right, so one cool thing, I'll show you this in a second. There's a utility called the Quixel Megascans Library Online that is a kind of a central repository for all of these different materials, surfaces. There's a team of people that works for this company, Quixel, that goes out into the field in all of these different areas with some pretty high-end cameras, and I think they even use some scanning equipment some laser scanning equipment. But what they do is they find unique objects, they scan them, they process them, and then they put them up on their website for download. So what I'm about to show you here, and maybe instead of showing all 6 versions of this, I'll just kind of show the most detailed and then the lowest detailed. But they put these objects, these mesh objects, up on their website, and you have the ability to download them to different levels of detail. Now, for us coming from the architectural space, we would think, okay, well, the lower the LOD, the less detailed it's going to be. It's kind of flipped the way they have these. So LOD 0 is actually the most detailed, and then the LOD 5 is the least detailed or least dense mesh. So I'm going to start with the LOD 0 here and open this up. This is just an FBX file. So those of you that are familiar, an FBX is just a kind of basically a surface file that can also contain or tie a material to it. So natively, I could have packaged this up as an FBX with the material. I'm just going to quickly piece that together during the presentation here. But this little statue that I downloaded is just a mesh surface. And you can see with wireframe turned on in 3ds Max, it's a pretty dense mesh. It's actually not too bad. The scan's not bad at all. If we look at it from the surface, you know, initially this might not look all that great. It's a good surface, it's from a scan, but this was put together using photogrammetry. And just to compare this to a lower level of detail, I'm going to import another one at our LOD5. And it comes in right on top. So slide this over. All right. So really, you know, you can tell pretty much right away, even with the shaded material here, that yes, this one on the left is much more detailed than the one on the right. The reason that I'm going into this LOD discussion or the LOD explanation is that when we're working in really large files, it's something that we have to consider. If we're putting together a large landscape, or if we're bringing things into a visualization program like 3ds Max or like Twinmotion, we need to kind of make a decision. Is this something that's going to be an area of focus? If yes, then we probably want to have a more detailed mesh. So we want to keep that, you know, to a higher poly level. If it's something that's kind of off in the distance and we're not going to be right on top of it, either in a rendering, a video, animation, walkthrough, then we can get away with it being less detailed, which ultimately overall is going to affect the performance of your immersive experience if you're using VR or something else. So just you know, to see the differences between these two, I like to show that, and I'm going to show them with edge faces. Obviously, turning that on, we can see the one on the left much more dense, much more detailed than the one on the right, as if we couldn't tell without the wireframe turned on. Now, another thing that I like to show, and the reason I'm in 3ds Max right now, and it's really not the focus of this presentation, but we can build these little artifacts or assets within 3ds Max. We can manipulate them using all of the tools that we have to edit meshes inside of 3ds Max. So I think this is just a, you know, if we turn the vertices on, we can start to manipulate, delete things out, add detail to them, you know, optimize the mesh. So maybe whatever program you're using, if you're using like that 3DF Zephyr to create photogrammetry, if you have access to a program like 3ds Max, then we can use Pro Optimizer modifiers to make the mesh less dense and to make it more performance enhanced. Now, with that, there are some tricks we can always get away with in visualization without having something this dense. We can always tie in a nice material. And so one of the other added benefits of using photogrammetry is that we're also collecting surface data when we create these objects. So go into, I've got Arnold, come on, there we go. I'm just going to pull in, I had this all set up, but you know, it happens. So with the standard material here, I'm just going to tie in the image data that comes with this download, which is the basically the bitmap that goes along with the scan. So just tie in a bitmap, bounce back to where I have this downloaded. And I'm going to pull this albedo, which is just the diffuse material or the color map. And I'm going to tie this to this material. So that's my base color. And then I'm just going to drop the material onto the object. So with just the diffuse, and I still have this shiny, you know, we can adjust things like the roughness in 3ds Max so it's not so shiny, it looks more realistic. Let me adjust my specular down so it's not shining. Let's turn these edge faces off. Uh-oh, without it crashing on me. Okay, cool. So pretty cool. We can see the 3D object. If I go into an isolation of it, trying to work on one monitor is always fun in 3ds Max. But you can see, you know, once you assign that material to the high density object, it looks pretty good. You know, some of the issues that we had with the surface, just with the texture map or the bitmap tied to it, look pretty nice. Now you also have the option when you download off of the Quixel Megascans to download the normal map. So I've got that as well. Come on, pull my node out here. Bitmap. I don't know why it's doing this with my preview, but it's all spaced out here. So there's the normal. And once I bring this in, you'll even see this added kind of additional level of texturing and shading once that catches up. So when you do this with photogrammetry, yes, we're collecting this mesh surface. We don't have to have it extremely high density because it's also gathering these different maps when you process this with photogrammetry. So you can use something like the more simplified version of the statue, tie in that normal map, and again, without rendering this, you can still see it looks pretty good on my screen. And I'll show better examples of this in Twinmotion, kind of adjusting the bump maps and whatnot. But pretty cool application. If I want to check out, just to kind of give everyone an idea of what the polygon count is, if you're into ArcViz. Where am I at here? Losing my train of thought. Okay, there we go. Stats. I'm just going to show my statistics. So this one's got, you know, 14,000 polys. If I get out of the isolation mode, go to the one on the right, isolate this one, 1,300. So a lot less dense than that LOD0. And obviously for this, yeah, it's probably, even with the material assigned to it, we're probably not going to get the result of what we want. But, you know, once you tie that material in, hey, if I'm 30 feet away from that object, I've got 1/10 of the polys, and really from that far away, you're not going to notice a difference in that surface. So some of the tricks, you know, to keep in mind when working with these things. And as I mentioned before, when you have a program like 3ds Max to process these objects, you can always go in and assign something like a Pro Optimizer. So what we started with, 13,000 or something, I can make that optimized down. So when you download them from Quixel Megascans, yes, we have these different levels of levels of detail that we can download. But if you're processing this on your own, having a program like 3ds Max just makes life a lot easier. So if you have a really, really dense mesh, or sometimes when you have something that you're processing using photogrammetry, there will be these little like surface details around the object that you want to delete out, and you can do all of that inside of 3ds Max. So let me pause there. I don't think there was anything else that I really wanted to show here, so I will close this out. And let's see here, launch up Twinmotion. And while I'm doing that, I don't know why this keeps saying this, just had to update. Don't give me some issue. That's interesting. Okay, let me try going through this other way. Now, with Quixel, so just kind of bridge what I was talking about with this Quixel Megascans, and hopefully I'm able to launch Twinmotion here. I've never gotten that message before. And it's not even showing my, let that load. All right, so with Megascans, when you purchase Twinmotion, which is a really reasonable price point, and we're running a promo, I think through March, for a seat of Twinmotion, it's somewhere around $330. So if you're comparing that to programs like Lumion and Enscape, it's significantly lower in cost, and it does a lot of the same things, and actually some things much better than those other programs. But with it, when you purchase Twinmotion, you also have an unlimited license to this Quixel Megascans library. So most of the stuff I would say on here is more for different artifacts that we would build into like a landscape, or maybe not even landscape, but more of like a video game type of scene. But there definitely are different artifacts in here that we would use for architectural rendering. You know, in one of them on this front page, you know, decorative planters. They're all different types of materials, which are obviously really good for creating high-end visualizations for architectural renderings. Since we partnered with Epic back in probably end of May last year, they've added, I think, around 3,000 new assets to this. So they're constantly expanding it. All of these are captured using the photogrammetry technology. So pretty cool stuff. If I search for statue, for example, we have 3D assets that we can download. This was one that hopefully, if I can get Twinmotion to launch up, I was going to show. You know, but it's a really detailed texture. When you download these, they come with the option of all of these different maps, all of these different levels of detail. And this one actually goes all the way up to 8 because it's just such a detailed object. Again, 0 being the most detailed, but some pretty cool stuff. And when you do purchase Twinmotion, using your Epic user account, you get access to all of this. So pretty great. Outside of that, so outside of Megascans, you also get access to the Quixel Mixer, which if you're really into editing materials and working on different materials, it's a great little utility to basically do 3D painting and working on your textures and layering your textures. Think of it like Photoshop, but for 3D objects. And there's also a bridge download that connects anything that you download from Megascans directly into the Unreal Engine, if you're using the Unreal Engine for developing apps.